Hello and welcome in this video for this exercise about optimization, and you want to determine the nature of the critical point or critical points of this function f of xy equals xy minus 1 over x minus 1 over y. So if you want to give a try, please pause the video. Otherwise, let's see the solution. So first, we are going to set the domain of definition, and the domain of definition, this is all the value of real numbers except if x equals 0 and y equals 0. Then, if you want to find the critical point or critical points, you need to calculate the first order partial derivative and set that equal to 0. Then, to determine the nature of this point, you need to calculate capital D, and this is the second order partial derivative with respect to x times second order partial derivative with respect to y minus second order partial derivative with respect to y and to x squared. So let's start. We are going to calculate the first order partial derivative. This is the economic notation, and this is more or less US notation. So this is y plus 1 over x squared, and this is equal to 0. Then the partial derivative with respect to y, this is x plus 1 over y squared, and this is equal to 0. So if you want to solve the system, one way to do that is to express an unknown function of another one. So let's say that y, this is negative 1 over x squared. Then the next step, this is to plug this value in the second equation. Let's do that. Okay, so this is x plus 1 over negative 1 over x squared squared, and this is equal to 0. So if you do the math, you end up with x plus x to the 4 equals 0. So you want to solve this to know the value or the values of x. So the common factor is x. So this is x times 1 plus x cubed equals 0. Then at this time, two cases. First case, x equals 0, and the second case, x cubed equals negative 1. So 0 doesn't belong to the domain of definition, as we said earlier, and the second one, x cubed equals negative 1. This is possible if and only if x equals negative 1. So now we know the value of x. Then we are going to plug the value of x in one equation. The first one, for example, to get the value of y, and y equals negative 1 over x squared, and if x equals negative 1, this is negative 1. So at this stage, there is a single critical point, and this is point A. You give a name to this point, and this is negative 1 and negative 1. So next step, this is to find out the nature of this point. We are going to calculate the second order partial derivative with respect to x. This is negative 2 over x cubed. The second order partial derivative with respect to y, this is negative 2 over y cubed. And the second order partial derivative with respect to y, then with respect to x, and this is 1. So now, at this point, -1, -1, the second order derivative with respect to x, you just plug the value of x. This is -2 over -1 cube, and this is 2. We do exactly the same with the second order partial derivative with respect to y. This is -2, and this is -1, the value of y, cube. And you end up with 2. So next steps, you calculate capital D, and this is 2 times 2 minus 1 squared, and this is 3, and 3 is a strictly positive number. So when D is strictly positive, then you need to focus on the sign of the second order partial derivative with respect to x. We already calculated it, and this is 2. This is a strictly positive number. So you can conclude that A is a minimum. Thanks for watching this video, and I hope to see you in the next one.